we're going to do an overview of functions and a function's domain, codomain, and range. Up until now, we've been talking about a single set that has a number of elements in it. What we would like to do is introduce the idea of two sets. So I'm going to start with a set S, and this is going to be all of the students in the computer science program. And then we're going to have a second set. I'm going to label this set V. This is going to be a list or a set of all the vehicles in the parking lot. We want to find some way to map an element in set S to a single element in set V. And we're going to use a function to do that. For our purposes, we're going to define a function as a set of ordered pairs. Let's call this ordered pairs, let's call it the first element will be S and the second element will be V. And it's going to have a first element, let's call the first element S, and the second element, we will call that second element V. So we're going to define some function F that is going to map students to vehicles in the parking lot. So the first thing is we're going to have a student named Stacy, and she is going to be mapped to a Jeep. The next set of ordered pairs is going to be Herb, and he is going to be matched to a Prius. Our third set of ordered pairs is going to be George, and George is going to be mapped to an F-150. And finally, we're going to have Lacey, and Lacey is going to be mapped to a Harley. So let's define the domain. The domain is the set of all first elements. For our function F, the domain of F is going to be first elements. Well, I see Stacy is the first element in the first ordered pair. Herb is the first element in the second ordered pair. Then we have George and we have Lacey. And this is the set of all first elements. The next thing that we can say about this function is that it has a range. And the range is defined as the set of all second elements. In our function, the range of F is going to be the second elements. I see that we have a Jeep, we have a Prius, we have a F-150, and then we have a Harley. The third thing that we can tell about this function F is that it has a codomain. A codomain is all of the elements in the second set, or all of the elements in set V. For our function, that would be defined as all of the elements in set V. So if I were to say the codomain of our function F is the set of all vehicles in the parking lot. Now, this is not all the vehicles in the world, it's only all of the vehicles in the parking lot, because that was originally what we defined our set V to be. So let me ask you this question. Does the codomain have to equal the range? The answer to that is no. No, it doesn't. There are times when the codomain will not equal the range. Consider the fact that if our function is mapping students to vehicles in the parking lot, there's a very good chance that there are a number of vehicles in the parking lot that do not belong to students. And if the range is a list of all of the cars that belong to students, and the codomain is all cars in the parking lot, that means that the range is just going to be a subset of the cars in the parking lot, because there's a very good chance that there are cars that belong to faculty, and there are cars that belong to staff, and there's cars that belong to visitors who are illegally parking in the parking lot. And in this case, the The range is just going to be a subset of all of the cars in the parking lot. Now there might be a chance when the codomain is equal to the range. Let's say, for instance, that the first set is the set of all students in this class, and the second set is the set of all seats that are available in the class. If the class is full and I were to map students to the seats, then the range is going to be all seats in the class because the class is full. The codomain is going to be all seats in the class. And under this condition, the codomain would equal the range because the class is full and all of the seats are taken up by students. Anyway, so if you have any questions about this, let me know.